Okay, so my name is Syma Khalid, and my role is I'm the professor of computational microbiology in the biochemistry department at the University of Oxford, and I'm also a tutorial fellow in biochemistry at St Anne's College. So my background is that I suppose I'm the child of first generation immigrants from northern Pakistan. My parents came to Britain when they were teenagers, and I'm the eldest child. So actually started school without actually being able to speak a word of English, and without really knowing what things were about. So it was a bit of a steep learning curve. But quickly sort of settled in and found I was quite good at sport, and I think that was quite somewhere for me to hide, to be honest, and wasn't a natural academic by any stretch of the imagination. But then later on, as I went through school, I guess I got more and more interested in science, but I'd always had an interest in literature and art, and so even then at that late stage, it wasn't that obvious what I was going to do. And I think, as with many, maybe South Asian families and others might recognize this, that my parents, certainly my mum, was quite keen on me to go into medicine. I was less keen. I wasn't so interested in blood and gore, but in a bizarre way, luckily for me, I didn't do so well in my A levels, and so medicine was out. But I was good at chemistry, and so I was really fortunate. The University of Warwick gave me a chance, and I went there to read chemistry, and I think just didn't really look back. So I really got bitten by the chemistry bug, stayed there for 7 years. So I did my degree, did my PhD. Then I moved to Oxford to do a postdoc in the biochemistry department, where I am now. But in the interim period, I spent 15 years then at Southampton, started off my own research lab and progressed through the ranks to professor. And then about just over 3 years ago, Oxford hired me back here, as I said, in biochemistry and at St Anne's College. So, what do I do? I think it's one of those things that can be difficult to explain in the sense that no one really does this topic at school. And so, we think about science really as physics, chemistry, biology. And what I do really sits at the intersection of all of these. So one way of thinking about it is that I make movies on the computer of how molecules are likely to move around. And in particular, I'm interested in how do bacteria protect themselves. And so it turns out that all cells have a protective layer around them. And for me, it's particularly interesting that how is it that bacteria have such a formidable one that we keep applying them with, we keep attacking them with antibiotics and nothing seems to get through. And so what we do is we use the principles of physics, chemistry, and biology and make models inside computers and then move them around and in a realistic way to sort of get a prediction of this is what's happening inside. So the reason I'm interested in this work and the reason I do it is there's two reasons really. First and foremost, fundamental understanding of the world we're in. And I'm a firm believer in that there doesn't always have to be an immediate application. Just knowing and understanding the world we're in is in itself a laudable aim. And I think one way of looking at it, certainly for me, is that of a really civilized society, knowledge for its own sake is a worthy endeavor. It doesn't have to always, and indeed, often there can be an application that then comes along many years later. But the other side of this is that we are at a real tipping point with antibiotics. Very, very soon, there will be no antibiotics left that work. We've already had one horrible pandemic, and that was viral in origin. It's highly likely the next one will be bacterial. And so, this understanding that we're developing of how basically what are the frailties and the vulnerabilities in the armor of bacteria, then the hope is that we pass this knowledge on to the medicinal chemists and they can develop new antibiotics. So, what I'll be talking about in my lecture is really some of it's what we've just talked about, what I do, how I do it, why I do it, but also a little bit about the legacy of Ibn Sina and how there may be how in many ways I guess we're all indebted to him as scientists in terms of the enormous open mind actually he had. It's almost it's very difficult for me now in these almost siloed way we work now and have to and specialized ways we work to appreciate how someone could have been a polymath and I think it brings some interesting ideas into play about the freedoms he had to think in the way he did. And perhaps we shouldn't lose sight of that. So there'll be an element of that. I'm very much going to looking forward to a trip to Bradford to deliver it. So, as a kid, we used to go to Bradford quite a lot. So, sort of distant family and relatives who perhaps we don't see very often now. In fact, very often at all. But the city certainly has its appeal to me. I like, in general, sort of the architecture of the buildings. There's the dark stone that's often used, and the sort of big old houses. It holds a real appeal for me. So yeah, I'm very much looking forward to it.